Thanks for coming, everyone. My name is Yogesh Girikumar. I am a DevOps architect at Humanitarian Openstreetmap Team. And I'm here to talk about some efforts that we undertook to modernize the hot tasking manager infrastructure. A brief introduction about Humanitarian Openstreetmap Team. It's an international non-profit NGO dedicated to humanitarian action. And most of its work revolves around collecting open data and helping people contribute to open mapping efforts. And all of its data usually goes into OpenStreetMap. HOT also has a mandate to support community development and community organization around geospatial. So that's the primary mandate. But HOT also does training and basically other activities to support the community and overall support the mission of OpenStreetMap itself. Today I'm going to be talking about HOT Tasking Manager. So before that, let's look at what Tasking Manager is. Tasking Manager is a coordination tool for collaboratively mapping onto OpenStreetMap. So it has it's a tool where people can create projects that are specific to a certain area of interest. And the area of interest is split into several small grids, and each grid is assigned to a volunteer with instructions on how to map. And whatever they map is uploaded to OpenStreetMap, and there are qualified validators who validate the data. This is the general overview of what Tasking Manager is for. It can be used for any purpose, really, but the HOT Tasking Manager, meaning the instance of Tasking Manager that is operated by HOT, you can reach it at tasks.hotosm.org. It's specifically focused on humanitarian action, humanitarian response. So it is very difficult to understate the impact that HOT Tasking Manager has had. So to give you just one example, in the recent response, HOT Tasking Manager was used to map over 2 million buildings, 80,000 kilometers worth of roads, and over 9,000 individual contributors actually contributed. Which brings me back to the tagline that I added. It actually solves problems of thousands of people with the help of thousands of people who were usually remote. So that said, let's look at the general tech stack of Tasking Manager. We have a static front end, React-based, and we have a Python-based backend, which also acts as an API to the database, which is Postgres. And all of this currently, the hot instance of Tasking Manager is hosted on AWS. The current infrastructure is fairly straightforward and fairly legacy. The static front end is stored on S3 and served by CloudFront CDN. The backend is stored on EC2 instances that are in an auto-scale group, so it scales up and down based on load. And the database is standard RDS PostgreSQL instance. The backend usually speaks to OpenStreetMap for authentication. So if you want to map using Tasking Manager, you need an OpenStreetMap account. And the backend also takes care of writing to and reading from OpenStreetMap. And currently, all of this deployment of the infrastructure is done using CloudFormation templates because it's completely AWS-based at the moment. We also have certain third-party vendors that help us monitor the stack. We use New Relic for application process performance monitoring. We have Sentry for error traces and CloudWatch logs for, log collection. So as you can see, it's a little fragmented. Deployments are actually done via CircleCI, which calls CloudFormation, which basically updates the stack or deploys a new stack. Database backups are usually handled by AWS scheduled backups, but also we have scripts because we had some interesting experience in the past losing databases. So we make sure that we have redundancies. There are several challenges that come with this, of course. The primary challenge being that it's really old and it hasn't been worked on for quite some time. We are fixing it. The infrastructure itself, the capacity of the EC2 instance and RDS are quite rigid. We have a set instance type for both of them. And when you want to change it, you have to update the whole stack, which leads to downtimes. And because it's so rigid and because the tool itself is very critical and being used constantly, we are a little apprehensive about updating it unless it is absolutely essential. And usually we update it to make it bigger, not smaller. That leads to it being quite expensive. We have we've had issues with deployments, and because of the way the instances bootstrap, the backend instances, deployments are slow. All the auto-scaling group has to tell CloudFormation that deployments are done, and only then will the deployments be considered complete. So that makes infrastructure changes slow and not quite straightforward. We also have a problem of legacy services being used, specifically launch configuration in AWS, which has since been deprecated. We also have had challenges handling security patches and just overall security of the architecture itself. So all that said, what are we doing about it? So we went back to the drawing board and we came up with roughly this, what you see on the right. I'll rationalize the decision for using some of these services a little later. But we decided to go with AWS Amplify, which is a quote-unquote serverless service that AWS offers. I say quote-unquote because it's not really serverless. But yeah, it makes it really easy for us to deploy our front-end site. It's a front-end app. It does both building the front-end and using CloudFront Edge to serve the front-end. So that makes things fairly simple for us. We can knock one thing off the pipeline. So the back-end is deployed on AWS ECS now, Elastic Container Service, meaning the backend is now containerized as opposed to running as a installed application on EC2 instances. So that makes the backend quite easy to scale and very fast to scale up and down as well. So there is the bootstrap issue that I talked about earlier is now handled. And we are embracing the serverless architecture. Again, I'll rationalize some of these and I'll give you some caveats later. So we have also introduced some tooling for security, including third-party vendors to do scans of our container images, make sure that our architecture is robust in terms of, and all the principles of least privilege are applied to the infrastructure architecture itself. We also have monitoring sidecars to ship logs to our log services. Currently, our observability tools remain the same, but we are planning to implement OpenTelemetry in the hopes that we can make it more or less vendor neutral for people who want to deploy, who don't want to use the conventional cloud platforms. We have better VPC architecture. By better, I mean like slightly well thought out VPC architecture, which brings us to some nice improvements. The VPC architecture that I talked about brings in some quality network improvements. We have IPv6 enabled across the board. We have proper network segmentation now. And we have a good handle on how to silo different services should the need arise. We are also have embraced, like I said, serverless services. Primarily because it gives us an edge on it gives us an advantage on costs. AWS is now, the RDS service is now using Aurora, which is a serverless service. So the advantage of Aurora is that you can scale the database down to nearly zero, but not quite. And then you can scale it up in a matter of seconds to handle any amount of load that's thrown at it. So this brings in a little level of unpredictability that we are hoping to get a handle on, but then it's also quite useful to get a grip on the costs. We have really fast service scaling of ECS, which is a big deal when it comes to user experience. Performance really takes a hit when scaling is slow. And when the usage drops, when scaling does not come down fast enough, then we incur costs. And both of those problems are addressed here. And we made a conscious decision to use Debian for our container images, which brings in a level of predictability in what packages we need to patch and how to install stuff, basically, if I can simplify it that way. And the nice thing is we are using Debian Bookworm with Python. Immediately, the next day after the Python Docker images came out with Debian Bookworm, it was in. And all of this has improved developer experience. This enables us to offer the developers self-service infrastructure, meaning they can spin up and spin down their own mini tasking manager with the sample data and Postgres whenever they want. Since everything is containerized, it's quite fast and ephemeral. They can bring it up, and when they are done testing whatever changes they want to test, they can destroy it. So we also have a few other things that we hadn't given a lot of thought to that we wanted to address. We have better SLI and SLO and tighter error budgets to make sure that we hold ourselves to slightly more restrictive accountability, better for the users and the community. And we have focused on continuous deployment. This piece is not in yet, but it will be, meaning that so far the quote-unquote continuous integration that we have had has only been continuous testing of the functional units. So we have also focused on making sure that the integration testing actually happens, like all the components speak to each other, and the testing gives us some meaningful insight into how the application is performing and where the bugs are, or where the performance errors are. We also have a much better thought out observability metrics. Specifically, we have been thinking in terms of averages, which is useful in its own right, but I think we would benefit more from thinking in terms of percentiles, like what percentage of users are served the application in under 100 milliseconds, for example, which actually makes it slightly actionable if we find a graph that we don't agree with. And all of this has reduced specifically the bootstrap time reduction has reduced alerts, and therefore like the developers and the DevOps engineers, aka me and my colleagues, get fewer alerts, and therefore we are spared some of the alert fatigue. All of this has made it easier to focus on things that the community gives us. So we have had some of our pull requests stay for several weeks now, which is an understatement, as some of people here would attest to. But yeah, it has really given the developers some extra time to focus on other things that actually meaningfully improve the experience of Tasking Manager for everybody. Just a note, I mentioned that I would rationalize some of the decisions. So earlier there was a lot of, I was in a quandary on whether or not to use some of the services that AWS offers that does not have an analog in other cloud services, because our Tasking Manager infrastructure specifically and HOTS applications in general are supported by grants offered generously by AWS and Microsoft. And when you trial and error, and when you spin up and spin down, and when you have fancy stuff like ephemeral tasking managers that developers tend to bring up quite often, grants tend to dry up. And there are some caveats that grants come with. For example, you cannot, for those who are familiar with AWS, you cannot reserve an instance when you are with the grants that you have. So we have to be able to port the application from one cloud to the next, or one account to the next, wherever the money is, which is a tricky thing, and it's scary to do it when you rely on AWS-specific services such as Lambdas and other serverless applications. But we thought there would be a good middle ground to move to cloud-agnostic infrastructure as code helpers like Terraform. There is a lot of effort involved, no doubt. We have to write a Terraform module for the AWS component. I mean, we have to write a Terraform module for the Azure component. And you have to bring up one and then spin the other one down. And there is also obviously the headache of having to move the data from the database PG dump and then upload it to S3 and then move it to Azure and then pull it back down. That's the simplest flow that I can think of, but there are obviously better ways. And especially when the database volume spans in the terabytes, then it's a it's a problem. And I have good reason to believe the cloud providers throttle network between themselves, so that's a different story. So this Terraform approach gives us a good scaffolding for dealing with multi-cloud deployment. And we are having to constantly kind of juggle the costs with performance and flexibility of deployment. I think we have reached a good compromise with acceptable trade-offs as far as hot tasking manager is concerned. So we will continue to investigate and see if there are any avenues for improvement. So this is in general some of the improvements that we have had in hot tasking manager. If you have any questions, definitely you should speak to me or any of the hot members. I would like to give shout-outs to some of the people who have helped us along the way. My job has been made infinitely easier because these people did most of the heavy lifting, I would say. Ramya is the product owner of Tasking Manager currently, and DK Benjamin is my boss. So yeah, they have done most of the work, and obviously we have had Kathmandu Living Labs help us a lot along the way. They have been taking care of updating and patching Tasking Manager, and Tasking Manager is so much better now due to the work that Kathmandu Living Labs has done. And obviously there are the people who do the thankless job of contributing to random GitHub projects, and I would like to give a shout out to Taylor and Sam. Sam is sitting right there. And yeah, so thank you all. If you want to, if you're interested in the impact that Humanitarian Openstreetmap has had, please read the impact report that came out for the previous year. It's amazing. We do some really good work, and if you have a lot of money, we could use a lot of it. And if you have a lot of time, and we could use a lot of your time to have with Tasking Manager, and if you would like to complain about a bug or two or more, you can. That's the link for that. So thank you all very much, and if you have any questions, please ask.